This movie is about how to call functions in R. Let's begin with a simple, helpful function, print. To call the function, I need to supply it with one input, and that is what needs to be printed. The technical term for this value right here is called an argument. That's what we pass into a function. And here I'm using the string literal hello, and it prints out hello. Now let's switch to a function that has more possible inputs, more arguments. Another technical term. When we look at the help, or which often includes the definition of the function, we call it a parameter. And when we call the function, execute the function, the value we pass in is the argument. And whenever we call a function, we need to have the arguments match up with the parameters. So for sequence, where we're going to focus on these three parameters, from, to, and by, so the starting point, the stopping point, and the step size of our sequence, we need some way of having R understand which argument is for from, which is for to, and which is for by. If I supply it with sequence 1, 5, then it's going to match up this argument 1 with the parameter from, because it's going to go by position. The first argument is going to be associated with the first parameter, and the second argument 5 is going to be associated with the second parameter, which is 2to. So that should produce the sequence 1, 2, 3, 4, 5, which it does. Now this function here, seek, has what are called default values associated with each parameter. So if you don't supply a value for from, it's going to use 1. If you don't supply a value for to, it's going to use 1. And if you don't supply a value for by, it's going to calculate the step for you. And for these integer sequences, it's going to be 1. So the implication here is that I can call sequence without any input, and it'll just give me 1. And notice, even though it's got 5 parameters, because they've all got default values, I can supply a subset of them. So for example, if I wanted to do 1, 3, 5, I could do the 1 and the 5 that I've already done, and then make my step size 2. There's another way that R can match up arguments with parameters, and that is by name. You can actually include the name when you're calling the function. So I could say this: from is 1, to is 5, and by is 2. And I get the same sequence. And the beauty of this method of calling is that order no longer matters. So I could say, it's more natural for me to think about it as start, step, stop. I'm going to write it like that. This also has the advantage of being very readable. R can handle a mixture of arguments that need to be matched by position with arguments that are matched by name. So I could simply say 1, and then I could say by is 2, and 2 is 5. And we have the same thing. R is rather sophisticated in how it does its matching up. I don't really recommend doing things out of order like this, but we could say from is 1, and then give it the number 2, and then say 2 is 5. And what R will do is it will say, I'm matching from by name and to by name. This value right here, the number 2, doesn't have a name associated with it, so I need to do it by position. So what I'm going to do is scan through all my parameters and say, have I already matched this by name? No. Have I already matched this by name? Have I already matched from by name? Yes. Have I already matched to by name? No, I haven't. So this number 2, I have already matched 2 by name. It's by that hasn't been matched yet. So this number 2 must be associated with by. So this must also be start at 1, go to 5, and step by 2. And it is. I recommend using the match by name. It just reduces confusion. So all the examples that we've had so far are having arguments that are either numbers or strings. So these are what are called literal values. You actually write the value and pass it into the function. But you could also use variables. So let's set up some variables. I have my starting point, which is 1, my stopping, which is 5, and my stepping, which is 2. And I could call seek like this: from equals starting, to equals stopping, and by equals stepping. Further, we could use something more complicated, not just refer to a variable, but we could actually use an expression involving variables. So let's use a simple mathematical expression. Let's say we want to go 2 bigger. So forget stopping at the stopping point. I'm going to go 1 big step further. I'm going to add 2 to that. So now my argument is actually the result of the expression stopping plus 2. So that should be 1, 3, 5, 7. And in fact, it is. So we've gone over so far how to match up arguments with parameters. That's either by position or by name. And what kinds of values or arguments can be. They can be literal values. They can be the values of variables. They can be the values of expressions. And I have one more example I want to show. And that is the fourth kind of thing an argument can be is it can be the output of another function. So one simple example is print needs an input. I could simply give print the output of calling seek. So here, the argument to print is the output of my seek function. Let's make an example we had in the earlier movie where our sequence was 5, 6, 7. From is 5, 2 is 7. So nums is 5, 6, 7. Awesome. Let me just show you that we can type mean of nums. That's a built-in function that NumPy had. R has. Or instead of saving the sequence in a variable named nums, I could just build it on the fly and pass it in. And there it is. The meme here took this output of calling the sequence function freshly rather than just from the variable. Thank you.